In this problem, we have a crankshaft that's connected to a bar that's connected to a piston. This crankshaft is rotating at 6 radians per second. It has an arm length of 50 millimeters. The bar is connected to the crankshaft and has a length of 175 millimeters, and it's at an angle of 60 degrees to the crankshaft, and at this instant in time the crankshaft is at 45 degrees. The piston is confined and can only move in the y direction. We want to find the velocity of the piston. To solve this problem, let's start by drawing what we have in a sketch form. If this is our crankshaft arm, and there's the bar arm, we know that the velocity on the crankshaft arm is going to go perpendicular to the crankshaft at an angle of 90 degrees. We know that it's rotating at 6 radians per second, so if we label this point A, this point P, the velocity at A is equal to omega of A times the radius, which in this case is equal to 6 times 50 millimeters, which would give us 300 millimeters per second. So this is 300 millimeters per second. We also know that at P this is confined, and so it can only go down or up. To find our instant center, we draw lines perpendicular to our velocities. So at P we draw a line in this direction, and at A we draw a line that should go in line with the shaft in that direction, meaning that our instant center is at this point here. Now let's label this distance here RA, and we'll label this distance RP. We know from our original drawing that this angle here is 45 degrees, and this angle is 60 degrees, and we have a length here of 175 millimeters. Now originally the crankshaft here was 50 millimeters, but we're not going to the end of the crankshaft now, we're going to the instant center, so this length is going to have to be different. So in order to find RA and RP, we're going to have to use the law of sines. Since we know that this length is 175 millimeters and this angle is 45, we can say that 175 is to the sine of 45, as RP is to the sine of 60 is equal to RA over the sine of 180, which is the sum of all the angles in the triangle, minus 60 plus 45. Solving these out, RP is equal to 175 sine of 60 divided by the sine of 45, which equals 214.3 millimeters. RA is equal to 175 times the sine of 75, which is 180 minus 60 plus 45, divided by sine 45, and that equals 239.1 millimeters. Now we know the velocity at A is 300 millimeters per second, so from our instant center, the velocity of A is equal to omega AP RA, which we said is 300 millimeters per second, which is equal to omega AB times the radius to A, 239.1 millimeters. Solving for omega AB, we get that omega AB is equal to 1.255 radians per second. Now that we know omega AB, we can find the velocity of P, knowing that that is equal to omega AB RP, which is 1.255 radians per second, times RP, which is 214.3 millimeters, which will give us a velocity of 269.0 millimeters per second, which is equal to 0.269 meters per second.